Okay, we're going to look into our module 6, but before that, let me share a little bit about your test 2 so that you aware we're going to have a test 2 on 1 January, which is New Year. Please check back the time. We did discuss last time already on the time and also that to have the test 2. So related to test 2, what preparation that you need to do is it's going to be separated into 2, which is part A and part B. For part A, it is a multiple choice and multiple choice question. It's going to be covered from water. It's going to be covered from module 5 and module 4, until module 6. So altogether, 3 modules, 4, 5, and 6. And for part A, it is okay because the marks for each question is normally between 1 and 2. So it's going to be like easy and moderate. Only that maybe on the easy part, it's quite like confused for you to answer. So read carefully the answer and pick which one is the correct, because normally we will give like quite similar on the answer just to make you confused. And 2 marks, which is in terms of the question like Boolean expression and etc. But it is only a few steps. Let's say you have A plus B plus C like this, and then you need to do the simplification using the Morgan theorem. So it will be A dot B dot C blah blah blah. So like one step or maybe another one more step. So only like 1 or 2 steps for question part A. But for part B, you need to be very careful because last time, I don't know whether you already done with other subject or not, but for part B, you need to download the question. Download the question. The question, I guess, in the PDF or words. So you need to download the question and you're going to answer your question in your own paper. You can write using your handwriting. You can write like maybe using your typing computer, but of course it's going to be hard, especially when you are playing around with the bar things, right? So it's better for you go for the handwriting. After you're done with that, what you need to do is you need to scan. You need to scan your answer script. If you don't have scanner, that is why you need to download now in your mobile phone, I guess a CamScan or maybe a similar application with this CamScan, because it's much more clear rather than you just pick a camera, normal camera, and normal camera is going to be like, I think JPEG. I don't know what the type. Maybe you can change the type, but it's not going to be PDF. But if CamScan, when you snap, it's going to be go for PDF. So that's why it's going to be a document. So you can directly upload to your e-learning. And normally, we're going to do the part A first, and then we give you a break like maybe 10 minutes before we're going to start the part A. So this part B. So you know already, right, how the flow from one part to another part. And for part B, we going to give you, let's say, to answer the question like 1 hour, let's say. 1 hour, and then we're going to say, okay, stop writing. We give you about like 15 minutes. This duration we not yet finalized, but this is like a draft only. So for you to figure out how the flow is. So maybe we're going to say, okay, we give you 15 minutes for you to upload your answer script to e-learning. So in this time, what you need to do, you need to like scan your document and convert it to PDF, or maybe you can like snap using your camera, or maybe using your any apps and convert to PDF. After that, you go to the e-learning and upload into your e-learning. So last time, normally it's happened to your senior when we ask them to stop here. We give another 15 minutes. What they did is they continue answer the question. They continue answer, and then after that, like, I have another 5 minutes, maybe another 5 minutes, I'm going to stop, and then I'm going to snap, and then I'm going to upload. That time, within 5 minutes, anything can happen. So don't wait until last minute. If you didn't start following what time we give, maybe your e-learning at that time is already down, or maybe your internet also down at end of 5 minutes. So don't do that, because it's always happen to your senior. I don't want to face this in this semester, so I already informed you earlier. So then please make sure don't do this. We give you enough time already for 15 minutes for you to upload your answer script, upload only. So it's supposed no problem at all, unless you continue answer and then you only occupy like 5 minutes or 10 minutes only for uploading your answer script. Then it's happened. Maybe suddenly your software that you download or apps you download corrupt, or maybe at that time also like maybe it's free use, so suddenly you cannot use it anymore. So it's always happen. So please learn from others' mistake. And if you cannot submit within the time given, normally we won't accept. So let's say you already finished, and if you submit, you get 80%. Then after that, you just submit, because although maybe there is another like a question that you didn't have enough time to answer. Compared to, but you already upload. But compared to like you continue, okay, I want to have another like 90% or maybe 100%, I want to go for 100%. And you occupy another 10 minutes just to answer, and you try to upload 5 minutes and you fail to upload. Then what you get? You get 0 instead of 80%. So which one you prefer, whether you want to have 80% or you want to get 0? And another one more thing, because this is part B, and this part B, normally part A is hard for us to check who upload into the, I guess it is check like this. I forgot the website name. There is a website that normally students upload the question to the website, and they need to pay, okay, to get the answer from expert. I think I already briefed last time what happened last semester. It's happened is when you upload, then it means that you are cheating. You are copying others and etc. So if you were guilty to do that, so what you need to do is you need to repeat back. If you repeat and always repeat, then maybe you were given maybe another punishment. So or maybe this time our director is much more like strict, I don't know. So please don't do that. Maybe last time they give your senior only to repeat. Maybe at this time there is another more punishments that might like very worse rather than last time. So who knows, right? So please don't do that. Please don't upload the question, because part B, normally student always upload because the time is longer, because normally it's like took like 1 hour 30 minutes. You cannot solve it. Maybe you can upload to the website and then you wait, because normally when you pay for the website to answer your question, is always like very fast one. So you get the answer and you upload your answer within the time frame. So if you do so, normally we will have the team to check into all the website, and we will try to find out basically in terms of your answer, and there is several way for us to check. That's why your senior been coached. If not, they maybe like already have gone through the digital logic subject. So we have the technique to find out who are doing that. So last time my section only, my section more than 8 students doing that. So they need to repeat. And compared to other section, also there is a lot of students from other section doing all together. So most of them repeat to take the digital logic, but not in the digital logic subject only. Another subject also are having similar and happen, because this is online examination. So we don't have like enough things to like always monitor you whether you are cheating or not, right? So don't do that in your test and also final exam. I already warning you, because we just discussing, we're going to open all the account into the website, which is a possibilities for student to upload the question. So be careful, not only for digital logic subject, and for those maybe you can answer, don't also give your answer to your friend, because that things also happen when suddenly your friend upload your own answer script. I think this one also I already mentioned. Let's say Ali can answer everything, so it's already 100%. He already answered, and then Abu asked Ali. So Ali give the answer script to Abu, but maybe Abu is like very like stressed at that time, or maybe in rush. What Abu did is he upload the answer script of Ali. So although is his name is Abu, but the name in the file in the answer script is Ali. So this is basically similar, which is 100% from Ali. So both of them need to repeat the subject. So don't share your answer to your friend also, okay? Maybe your friend also like maybe he did something wrong, and then it's like bring you and tag you in to the maybe the false or wrong that he did. So that is on your test too. How many question for part A and part B, I'm going to share later on. But for part B, it's come out, I guess, mostly on the problem statement from your module 5, isn't it? So that is very critical. You can go and find your senior, ask them past year question. That's why I asked you to like do a networking with your senior, with your junior, because this might help you. So there is a lot of hard or maybe critical or maybe I guess it's hard and tough question from previous semester related to problem statement. You can refer and try to answer. Normally it's very it took several time for you to just understand the sentences. So you need to very carefully read and write. If you just read without like taking out the keywords, I guess you're going to having a loop reading. And at the end, you get nothing, which is in terms of input, output, and the condition. But later on, before the task 2, we're going to also discuss much more detail. I just remind you because we just vetting the question yesterday, but we will do a second vetting after all other lecturers agree with our question. Okay, any question related to your test 2?
Doctor.
Yes.
For the part B, if we have the tablet or iPad, can we write on there, right?
Yes, can.
Okay.
Okay. So let's move to our module 6. So in our module 6, what we're going to look into is basic adder, parallel binary adder, blah 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 blah. Which is, this is all like a system. Last time you just learned on like gates. When you have a gate, you combine, and you have the combination logic circuit in terms of circuit. But with all this combination, you can have one function. Let's say it's going to be adder. When you combine together, it's going to be a comparator. Combine can be a decoder, encoder, and etc. So that is what you're going to learn in your module 6. And from this all, the adder especially, you can create your own calculator, how the calculator look like. What else? I think decoder and encoder, you can also create the segment 7-segment display, which is this is all the LED that make the display, like maybe you want to display number 7. So what's number what pin that will be used to trigger 7, what pin will trigger 8, what pin will trigger 1, and so on. So you're going to learn on this module, starting from this module. And for this part, I guess it's only covered for part A. It's only covered for part A, I think so, because yesterday we did the question together. I can see that all the module 6 to be in the part A. But although it's in part A, a lot of question will coming out, and it's touched for all subtopics here. And let's go through one by one. Basically, first thing we're going to look into basic adder. In basic adder, there is 2, which is half adder and also full adder. Half adder and full adder. So if you still remember on this arithmetic, which is it's going to be 0 plus 0 equal to 0. 0 plus 1 equal to 1. 1 plus 0 equal to 1. This is all SUM, sum. And 1 plus 1 is going to be 1, 0. 0 is sum, 1 is carry. And last time also I did give you these things, which is if you have 1 plus 1 plus 1, what is going to be? It's going to be carry as 1, sum as 1. So you need to remember all of this, especially on the adder. After that, what you're going to see is half adder. Okay, in all these like basic adder here, what you need to know, which is in terms of the block, how many input it have, how many output it have, what is the name of the output, and of course the input you know already is a variable, and this is in the block diagram here. But inside this block, you know this is half adder. You can just name this block in half adder. But what is the circuit inside? What is the combinations of the gates? Maybe the gate is look like this. Is it true or not? So you need to know also what is the circuit will make this to be half adder. After you know everything, you can construct the expression, Boolean expression for the output here. Whether the output, if let's say the output is 1, so you know, which is you have only one output, what is the Boolean expression? If you have 2 output, what is the Boolean expression, and etc. That is the things that you need to know on half adder and full adder. I guess for all others here, you need to know also in terms of whatever circuit is inside this block.
So doctor, was it an XOR gate and an AND gate for half adder?
Yeah.
Oh,
It's
okay.
the combination between exclusive OR and also AND gate. Okay, later we're going to look into inside, okay? So this is a block on the half adder. What you're going to use in terms of the input. The input only adding 1 bit number. So this is the requirement for half adder. If you have 2 bit number, you cannot use 1 half adder only. If like maybe you have 2 bit number, you need to have 2 half adder. You combine it together, then you can add. So if you have 3 bits, maybe you need to have another 3. So you can add all the number. But basically for 1 half adder, you can only add 1 bit number, which is you will have 2 input. Input A, input B, or maybe input X, input Y, as long as it is a 2 input there. Because why there is 2 input? Because in adding, if you have only 1, which number you want to add? So you need to have adding, which is you have something that to be add together. So you need to have 2 input. And then after that, you can see here you have a output. There is 2 output, which is sum and carry. Sum and carry. And for this sum, the expression will be A exclusive B. And another one, the carry is A and B. And of course, the scenario is following the exclusive O, and this one following the AND gate. Let's take a look what is basically inside. So this is basically the half adder. Just now you look into the block. So this is a half adder. You have XO, exclusive OR, and also AND gate inside the half adder. So with the combination of this, you will get the output of sum equal to A bar B plus A B bar. This one is all the expression last time you already know on the XO. If you have two input, how the XO will be look like. So all of this we will learn starting from module 1 and module 3. Look back on the XO expression. Then for the output, you can see here the output for C out is connected to the input of A and B to the AND gate. Then it's going to be A dot B. A dot B. So this is the carry out. So you can construct, because you have only two inputs, you going to have to the power of 2. You have 4 possibilities for the input. 0, 0, 0, 1, 1, 0, and 1, 1. If you want to remember, it's okay for you to remember the table, but in terms of maybe you can't remember, you can just construct the table. So this is the true table for your half adder. And you can use also, okay, before we go for full adder, is there any question for half adder? There is no way for you to like, kenapa jadi eraser? Okay, there is no way for you to skip, to memorize all of this. You need to memorize. Okay, then you need to know, okay, a half adder is a combination, and the combination connection also you need to see how basically the connection to the XO and also AND gate inside the half adder. Okay, let's move to full adder. So for full adder, there is a slightly different, because you can see here it accepts two inputs similar, and another one is input carry. So it's making all the input to be 3 inputs for the full adder. But for the output, it's going to be 2, which is sum and output carry. If you combine this full adder, 2 or more full adder, you're going to perform the parallel adder at the beginning of this one. When you have the combination of full adder, but this one, the combination later, we're going to look into the parallel adder. But first, in this stage, what you need to know is, you need to know how the full adder look like, how many input, how many output, and what is the connection or the circuit, logic circuit inside. So on the produce table, you still don't know, right, what is the circuit inside, but this is the output. So maybe you can like check one by one here. What is the combinations all of these, which is maybe without given the circuit. Let me see the CO first, okay, because this is a CO first. C out. I have here. Let me see what is the SOP Boolean expression. I have my A, B, C bar. I make it as a C in, okay? Here. Plus, this one is A B bar. Sorry. A bar. A bar B C. Plus A B bar C in plus A B C in. So this is my C out in terms of SOP standard. Can I try to simplify? This and this can simplify, I guess. A B C plus C bar. C plus C bar, what happened? It's going to be C. I forgot already. The rules. Anyone? Go to the rules and check the answer. You all tolong check ke tak ni?
1.
1 eh? Is it 1? I think that C plus 1 is going to be 1. Where is my 4A? Kenapa? Oh, sama juga. A plus 1 is 1. A plus A bar also is 1. Okay. Mana dia sini eh? Hilang dah. See out. A, B, C in bar plus A bar, B, C in plus A, B bar, C in plus A, B, C in. So this and this, I simplify, but it is nothing happen also. The rest is also similar, I cannot simplify. Okay, and the sum it will be kenapa banyak ni? It will be A bar B C in bar plus A B bar C in bar plus A bar B bar C in plus A B C in. So this is in terms of SOP standard. So please make sure you know how to construct from the truth table. And from this side, what will happen? Okay, this one is in terms of to find the simplification. You can see, is it correct or not for sum here? For this part, this part, this part, this part. So what you're going to have for here, 1, 0, 0. This one. And then this is 0, 0, 1. 0, 0, 1. Okay. Oh, my C is here. So my C is in front. But it is basically similar to this. You cannot simplify anymore. In terms of C out, you still can simplify. I do believe that you can still simplify this. You're going to get here AB plus C in B plus another one is at this side C in A. So this is the summarization, simplified version. So let's take a look into the output here. You can see this is our C out just now. And when you have all of these, you need this one we get from the CAM map. And then you can construct it to be in terms of XO bar, XO. You can see here, exclusive O, exclusive O. From here, lastly, you will get exclusive O here in terms of summarization. You can try to do step by step. But the final answer, without derivation, you need to memorize this and this. In terms of derivation, you need to know how to simplify it and how it's derived until this part. And from here, of course, when you have the Boolean expression, you can come out with the circuit. So this is the full adder. You can see here, this is your full adder. You have 3 input and 2 output. And in terms of this, basically it is a combination of 2 half adder, if you look carefully, plus with the O one here, 1 O, because you add 2 half adder, add is O. Where is my half adder? This is my half adder. This one, right? And there is another 1 half adder here. Supposedly, let's take a look beside. Supposedly it's 2 AND gate only. Might be this connection. Why it have 3 here? A, B, C, correct? And then supposedly it will be at the output. Okay, this one I guess this is picked directly. Kenapa tak boleh lukis? Okay, because this is directly from here without simplify another one more step. And lastly, you can construct the full adder with the following. This half adder, and this is another half adder, and you add with 1 O. So exclusive and exclusive here, exclusive and exclusive is this and this. After that, you're going to add, this one is the input from A, B, C. You can see A and B. Where is B? High. That's why this one is slightly different. Let me check. Okay, this is A and B, and this will be B and C, and this one will be C and C.
Sorry, Doctor, can you explain the simplification again?
What again? Me?
Simplification.
Simplification. Okay, wait. I want to check this one. A and C. Okay, this one is A and C. So this one is O. All together, all the O. This one is exclusive, which is A exclusive B. This one B exclusive C. Okay, in terms of simplification, first of all, you have the true table. From these 2 tables, you will construct the CAM map. When you have the CAM map, this is you need to do a grouping to have the simplification version. So from here, you group, and this one, you will have all the simplify. Then you can see here, it is factorized using C bar there, and it's stacking. This is C, and this is C. So you can see here, it's grouped like this. And for this one, it grouped like this. Okay, let me go and bring here. C bar, A bar, B plus A, B bar. So this is this side. And you have another plus with C here. A bar, B bar plus AB. That's why you have the second part. From this, if you still remember at this side, this is exclusive OR. When you have A bar B plus A B bar, it is exclusive OR. That's why you will have C A exclusive OR B. And then you have over here, this one is exclusive no. If you still remember this part, it is exclusive no. Check back your module 1 and 3. If you have A bar B bar plus AB, it is exclusive no. So you have C A exclusive no. So there is a bar over here at this side. This is the derivation for you to get the simplified.
Okay, got it, Doctor. Thank you.
Okay. So that's why after that you can simplify this. You can see this is another one, which is A bar B plus A bar B. This is exclusive OR. So this will be your A, this will be your B, this will be your A, this will be your B. So that's why you have another exclusive using the following. A is C bar, B is A plus B, and this one. So that's why finally you will get like this. So please try to do derive until you get this one. This is basically from your simplification. So it is not too hard because that will be already give you step by step here. At the end, you just need to know this part. Because the derivation is not problem as long as you know how to simplify. Kenapa pen saya hilang saja ni? Okay, so as long as from this truth table you can come up to the K-map, and then you can group and you get the simplified. When you have the simplified version over here, you can direct go and draw your circuit also by using this. But you can also simplify in terms of exclusive gates. That's why you will get finally at this part, the step that I showed you just now. And similar to your C up over here, you have this sum table. You come up with the K-map. You can group like this. And over here, the adjunction is like this. You can see you need to have from biggest to the smallest. And throughout, you will get this circuit. So this is the full adder, similar to this one. So this is the simplified version. You can see you have two half adder there, which is full adder actually can be viewed using two half adder and you're going to add it together, adding the OR. So please make sure you know how the connection look like. C out for the first adder will be connect to the OR here, and this will be another one. So in terms of full, let me draw the full part. This is your half adder. So this is your A, B, and there is a connection to your another half adder. Your C out, C in, sorry. Your C in is going to go to your another input for your half adder. Then you have the output for your sum. While there is another output for your half adder here, and there is another output for your half adder. This output and this output you add together to be your carry out. So this is the connection, how you connect basically your half adder to be your full adder. In terms of circuit, this is look like there is a half adder here and there is another half adder. And you add using the OR gate. And you can try to add the numbers. In terms of full adder here, when you have 1, 0, 0, what will happen? Because you add 3 numbers there, you can see what is your sum, what is your carry out. So you have A is 1, B is 0, C is up. You're going to have 1 plus 0 plus 1. You will have the sum as 1 and no carry, so the output will be 0. 1 plus 1 plus 0. We're going to get a sum of 0. Sum of 0 and your carry out will be 1. And another one is 101. It is also similar. Sum is 0, carry out is 1. So that is the answer and the example. If let's say you were given, determine the sum and the carry out of a half adder. This one is half adder, not the full adder. Half adder for each set of the input bit given. So you have 0, 1, 0, 1, 1, 0, 1, 1. This is your input. And you need to have the output. Last time you already remember the truth table, but if you didn't remember, you can memorize. This is your exclusive or this is your AND gate. A dot B.
Is it the opposite?
Wait. What again?
The AND gate is the say out or?
Why? No, I am checking now why it is 1010. Supposedly I think it's changing the place.
Yes, I think so.
Yeah, it's supposedly to be here. The see out and the carry out should be, yes. This one is AND gate. This is exclusive OR, the output. So I guess the solution is changing the place. So please make sure you check back in your textbook. I think textbook there is no error. So maybe on the slide only. So next is exercise 6.2. You can see this is full adder. Just now is half adder. So this table you already have in the early stage, which is I asked you. You can remember the table because you have only these 4 scenarios. But this one, this one is also wrong. Okay, this one is correct, which is our carry out is A dot B. This one is exclusive, so this one is correct. So you need to check carefully, and you can try to remember, and you can also just think about the output following your expression. If it is exclusive or what is happened, if A dot B, what is happened. Oh, this one is carry out. Of course, it's here. This is a sum. Of course, it's here. Okay, next is our full adder. Has a C in of 1. This C in is already given, so it stick at 1. What are the sum and the carry out when A is 1 and B is 1? So it's easy for you. You can always like adding like this. You will get what? 1, 1, isn't it? So you have the sum of 1 and carry of 1. You can try also in your did simulator. You can see here, this is your carry of 1 and the sum of 1. Okay, any question until here?
Doctor, why 1 plus 1 plus 1?
Why? You ask.
Why is it 1 plus 1 plus 1? Like, can't we just figure it out? Like, since A is 1, B is 1, since it's an XOR gate, so it's going to, yeah, like that, instead of like 1 plus 1 plus 1.
You can go directly one by one like this, which is full adder. You said you want to, where is my full adder? You want to go inside here, right? 1 plus 1, and then this one will be your exclusive OR. If 1 plus 1, what happened for exclusive OR? I remember. You want to go one by one also can. Maybe you have here 1 and then you have this one. So what is the answer for the sum, isn't it right?
Yeah.
Yeah, okay. You can do it one by one, which is, this one is the second, but you can also go for the direct one, which is, you know already that it is like 1 plus 1 plus 1. So you can have the table just now at the beginning slide, which is 1 plus 1 plus 1. You will get 1 for sum and 1 for carry. But in terms of the circuit, you can go and directly check one by one the things that you see. Why don't we go for 1 and 1 for A and B? Here is exclusive. All right. What is the answer? What is the answer?
0.
0. Okay, if let's say it's here is 0. So 0 here, and then our C is 1. 0 and 1, what happened? It will be 1.
1.
1. So your sum here is 1. So let's go and check at this side. You have, here is 1, and this one is 0. So you will get 0. Alright? And this part, it will be 1, and here is 1. So you have 1. That's why your output, C out is also 1. Okay, so you can go one by one like that. If you don't want, like, do 1 plus 1 plus 1, it becomes as 1 and 1. Am I answering your question?
Yes, doctor, but now I think I will just stick to 1 plus 1 plus 1 because it's easy.
Yes, but in terms of what happened inside, you need to know also, right? So that is happened, and that's why you get the output like this, which is, we know already 1 plus 1 plus 1 is become sum as 1, carry is 1. But later on, you will combine all the full adder. let me give you some overview what happened. So you're going to add, okay, like this. When you have full adder, right, you're going to add all these things. This is like full adder 1 and full adder 2. The input of carry in is already give at the starting point. Sometimes it give you 0, sometimes it give you 1. It's depend, right? Similar to your A and B. So let's say you are given with two numbers, which is A1 is 1, B2 is 0. Oh, okay. Let me give you the number first. A2, A1 is 1, 0. Okay. And my B2, B1 is 1, 1. Okay, I give you example only, okay? And at the starting, you will be given in your question, your C in will be, here is 0, right? Okay, your C in will be 0. So what happened? You need to know how to construct it. Then you have here B1 is 1 and A1 is 1. Here will be A2, A1 is 0. This one is 1, 1. So from here, you're going to see you will add 0 plus 1 plus 0. Then you're going to have sum 1. Your carry will be 0. 0 plus 1 plus 0 at this side. This will be your input. You add, you're going to have 0 and 1 and also 0 for carry. You can check also in terms of the circuit. You can put all the things just now we did into your XOR, into your AND. You will get the similar output. And this out, carry out, you're going to bring up here. Then you have 1 plus 1 plus 0. You will get what? 0 as a sum, carry as a 1. So your final answer will be 1, 0. And there is a question for your part A. You were given like A1, B2, B1, C in. Okay, which one will be your, I forgot the question. Which one will be your answer? I think so, which is at this side. So you need to know that will be your C out 1, sum and sum. Or maybe at this side. I forgot already how the type. But you need to know on how the connection look like. When you have two full adder, how you going to connect them together? There is a C out. It's not going to be output directly, but instead this carry out for your F1 here, it will be the feed and also input to another C in. It is not the beginning, you will be given the C in, right? It is not all the C in is 1, but the next C in will be getting the value from your output. If you have another full adder, your C in value is not from the initial value given at your question, but it will be fit from this one. If this is 0, then here will be 0. You will be given only the two value A1, A2, A1, A2, B1, B2, and the initial of C in value. If you have 3 full adder, you're going to have A3, B3. If you have 4, you're going to have A4, B4. But the C in only 1. You see in only 1 because you're going to pick only at the beginning. At the after that, all the C in is from your C out, So that will be a parallel adder. So that's why you need to know the very basic thing first at this side, similar on your half adder. You need to know if you have 1 plus 1 plus 1, what is the answer similar to your early table. This one. Because this is going to be at your half adder and full adder. If you have 1 plus 1 plus 1, what happened? If you have 1 plus 0, what happened? And etc. Okay, any question? Any other question? If there is no question, what I want to do is, after this, please contact your friend. Contact your friend, and which is the group I give you yesterday, and start dividing the lab 2 question and discuss, because you have like 45 minutes to do. Don't use this time with other things, because this is your digital logic subject. Okay, so any other question? So construct your group now, and then please try to finish, if you can finish it in terms of 45 minutes. If no, you can continue, but start from now. Okay, so we end our class today and meet you again in next class. Okay, bye bye.
Thank you, Doctor.
Okay, thank you.
Doctor, can I ask question, Doctor, about
Thank you, Doctor.
the lab?
Yes, can.
Yeah, and part B, it says negative odd and positive odd. Does that mean like we go back to model 3? Then
Wait, I open the lab. Wait, Okay, what is your question?
In part B, it says the rules says negative and positive numbers. So there are 4 inputs. Do we count from positive 7 as the highest bound and negative 7 is the lowest bound?
Which one is negative number? Wait.
And the rules, read the rules. Rule 1, rule 2.
Okay. E4 is activated if the input number is negative odd and the majority of.
So do we use the table that 0, 0, 0, 1 means positive 1 and 1, 0, 0, 1 negative 1?
Yes, supposedly, because it is a 4-bit. Let me go through it.
Yeah, it's we use the higher upper bound is 2 to the power of n minus 1, right?
Yes, this one.
Yeah. So
okay.
we get positive 7 as the higher bound, the upper bound, and negative 7.
Yes.
Oh, okay. All clear now.
0 is considered positive.
Because it's confusing, like it's written and the majority of the bits is 0.
Again?
Okay.
No, I can't hear you clearly.
You can hear me?
Yes.
Yeah, and the majority of the bits is 0. What does that mean? Does it like change anything? Or?
It is not, because that is depend on the question and situation that given.
Oh, okay.
So please make sure. I think there is experimental setup also. If you didn't do this, maybe there is another member, please also do it alone, because in your part B for your test 2, normally it's going to be on the problem statement basis. Okay, so it's much more tough because you're not given with like this kind of figure. You will just given with the statement. You need to know the current situation. Last time I give you about the COVID, right? Because last time also like past year, we still having a COVID situation. So normally we will give in terms of current situation, or maybe in the banjir one, flood and so on. So please make sure you know the current situation, then you can relate with the input and output. Okay.
Okay, doctor.
Okay.
Thank you.
Thank you.
Thank you, doctor.
Okay, bye bye.
Thank you, Doctor. Bye-bye.
Thank you, doctor.
Thank you, doctor.
Okay.
Thank you, doctor.
Okay.
Thank you, doctor.
Okay, bye bye.
Thank you, doctor.
Okay.